So in today's lesson, we're going to be thinking about theoretical probability, kind of comparing it to experimental like we did yesterday, where experimental probability was what's the chance that something actually is going to happen in the experiment. You roll the dice or you pull a card from a deck. What's the actual chance that happens in the experiment? And today's lesson is going to be in theory, what is the chance that something might happen? So you're thinking about all of the possible outcomes that might actually occur in that scenario. So the first do now question actually is experimental probability. There's a table here. Somebody rolled the dice, recorded their table, the number of rolls that happened there. And you're just going to answer these questions. What's the percent that they rolled the total, the 4? And what's the fraction of the total that resulted in an even number? So 2, 4, or 6. And remembering, we're practicing with fractions, decimals, percents. The first thing you'll need to do is figure out the total number of rolls. So that's just going to add up here what's in the frequency column. This total here will be all of the rolls that happen. So go ahead and add up this whole column. That's going to be your total. And then if you roll the 6, it would be a 1 out of whatever the total is as a fraction. Then if it asks for a percent, turn it to a decimal, multiply the decimal by 100 to get the percent. So go ahead and pause the video, answer these questions, and then come back when you have them, and we'll keep moving through the lesson. So those answers are posted in the notes on Edsby. So if you want to take a look, you can check your answer. And then also I would like you to grab a textbook and define theoretical probability. So go ahead and get that written down. Once you have that recorded in your notes, then continue with the lesson. But for now, pause the lesson because it's really important to understand what this term is because it's the main concept that we're working with in the whole lesson. So please pause the video now. And now let's talk about the theoretical probability of something happening. So if you had a coin and you flipped the coin and you wanted heads to show up, you need to think about how many heads are there on the coin and how many total outcomes are possible on the coin. So obviously there's only one head on a coin and there's a head and a tail. So there's 2 possible outcomes. The successful outcome would be rolling a head. There's only one. Total outcomes would be 2 because there's a head and a tail. So it's a half or 50% or 0.5 chance that would happen. When rolling a single dice, how many 4s are there? Well, we already know there's only one 4. Total possible outcomes is that there's 6 possible things that could be rolled on the dice. So it's a 1 in 6 chance. So how about drawing from a deck of cards, a regular deck of cards, an ace? So if you can't picture what a deck of cards looks like, then flip to the next page. And here is a deck of cards. It's not in color in your packet, but if you look here, I can see hearts, diamonds, spades, and clubs. And this question is asking me about drawing an ace. So how many aces are there? Well, there's an ace of spades, diamonds, hearts, and clubs. There's 4 aces in this deck of cards. And in a deck of cards, there's 52 possible outcomes. This is 4 out of 52. But we should reduce that. Grab your calculator if you're not quite sure, but there's 1 ace in every suit, and there's 13 cards in every suit. So it's a 4 out of 52, 4 out of 52 chance, or 1 out of 13 chance that would happen. And then the last scenario is a radio contest. Radio station held a contest. 100 people qualified, and there are going to be 10 winners. So what's the probability of being a winner? Well, there's 10 winners. That's successful outcomes that can happen out of 100. And that does reduce to 1 in 10 chance. So then you can make an informed decision. Do you want to enter this contest? Is it worth your time? Do you think you stand a chance of being a winner? Those are all in theory. Okay, we didn't actually enter contests. We didn't roll the dice. We didn't do any of that. We just in theory thought about the chances. A standard deck of cards has 52 cards in it. It would say plus jokers if they want you to add in the 2 jokers. There's 13 suits. Sorry. 4 suits, 13 cards in each suit, and it looks like this. So just use this picture as we're going through here. The question is first asking you, if you take 1 card from the deck of cards, what's the probability that a heart is going to be drawn? So if I'm working with a standard deck of cards, and I just grab a card from the standard deck of cards, and I just pull it out, it's a heart. It's not always going to be a 100% chance. So like these are randomized. So what are the chances that you're just going to reach in and just going to grab what you're hoping for? Well, if I look at my picture here, there are 13 hearts So right here, if I count them up, 13 hearts, there's 52 total chances. So it is a 13 out of 52 chance, but that reduces, and you probably already know it. It's a 1 in 4 chance. There are 4 suits, and one of those suits is hearts. So it's a 1 in 4 chance. How about an ace? Well, we just did this one. We know there's 4 aces, one of each suit out of a total of 54. So that's a 1 out of 13 chance. He says a heart, a club, or a jack. So a heart, there's 13 hearts. A club, I have to think club clovers. So there's 13 clubs and a jack. So there's a jack here and here, but we've already counted them. But there's a jack here and there's a jack here. So I actually could be drawing 28 cards and be considered successful out of my 52. And those are both even numbers. So definitely they reduce. If you aren't quite sure what that reduces to, grab a calculator, and it's a 7 out of 13 chance. D says, what are the chances that you're going to draw a black diamond? Well, you might be looking at this picture like, where are the black diamonds? How come I can't see them? Well, there are no black diamonds. So sometimes the questions can be tricky, and we do need to think about statistics very wisely. We need to analyze, am I being misrepresented? Are they saying things that it feels like might be true, but it actually is not true? It couldn't really happen. So in this chance, there's no chance, this scenario, there's no chance you're going to draw a black diamond. So it's a 0 out of 52 chance, or literally just a 0% chance that's going to happen. It will not happen. And then in E, I look here, the last thing that I'm going to think about is, what about drawing a heart, a club, a spade, or a diamond? Well, a heart, a club, I do the wrong one, club, a spade, or a diamond. Well, that's all the cards. So it's 52 out of 52. Definitely those will all be successful outcomes. You have a 100% chance that that is actually going to happen, because all you got to do is just reach in and grab any card and it's going to be one of those suits. All of that is in theory. Okay, so now we're going to switch to dice. I'm just going to show you two different ways of kind of keeping track of what your options are when you're rolling a pair of dice. This one is asking you what's the probability of rolling doubles. So 2 1s, 2 2s, 2 3s, 2 4s, 2 5s, 2 6s. We probably don't really need to even analyze this to figure it out, but I'm going to show you how to do a tree diagram or a table, because eventually the questions will end up getting a little bit more complex, and you definitely want to be able to organize all of your possible outcomes nicely. So with the tree diagram, first I just think about all my options. So my first dice, I could roll a 1, I could roll a 2, I could roll a 3, a 4, a 5, or a 6. And then think about all the options on the second dice. Well, I could roll a 1 on the first one and a 1 on the second one, or a 2, or a 3, or a 4, or a 5. And so it looks like branches on a tree. Hopefully you guys can squeeze yours in better than I can, but basically you do that with each of the numbers that are possible here. So with the 2, as my first dice, I could also roll a 1, a 2, 3, 4, 5, 6. For a 3, as my first dice, I could also roll all those things. And keep going with all of your possible numbers. Yeah, hopefully yours looks a little neater than mine, but anyways, we'll pretend like you guys can read that. 1, 2, 3, 4, 5, 6. Okay, now this is going to be very obvious to you guys because you can already think about this, but I have the options of a 1 and a 1, or I have the options of doubles that could be a 2 and a 2, or a 3 and a 3, or a 4 and a 4, 5 and a 5, or a 6 and a 6. So I have one out of each of those that could be a double. In total, I have 6 doubles that I could draw. And the denominator might be the harder part. Like, how many options of possible rolls could I have? Well, I have 6 in each of those sets. So 6 groups of 6 is 36 total possible different combinations I could have. But that does reduce to a 1 in 6 chance. In each of those sets, I have one double. I have 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So my reduced number is a 1 in 6 chance. This table is just going to help us see all the possible outcomes for the tree diagram. If that seemed very obvious to you, still practice it because we'll use that later on in the course. If you thought that was a little bit confusing, you could do a table. So I could have first dice and second dice. I'll just briefly show you kind of what you would do here. So I know I have a 1, 1, a 1, 2, a 1, 3, a 1, 4, a 1, 5, so on and so forth. You're going to keep going. And then you would circle all of your doubles and you would see exactly the same. We have a 1 in 6 chance because there's one pair in each of those combinations. Okay, that's all in theory. But now let's compare them. Is theoretical and the experimental the same? Are they close? Are they quite different? You know, how do they relate to each other? So in theory, what's the probability of drawing a club from a standard deck of cards? Well, we've kind of thought this through already, but clubs, there's 13 clubs out of 52, or clubs is one suit out of the 4 that exist in the standard deck of cards. So it's just 1 out of 4. What's the theoretical probability of drawing a 7 from a standard deck of cards? Well, there's 4 7s. So I know it's 4 out of 52, or there's 1 7 in each of the 4 suits that could be drawn. So 1 out of 13, because there's 13 cards in every suit. Or just go ahead and write that down as, I know it's 4 7s out of the 52 decks of cards, but then reduce that. Okay, so if you really do need to think through the whole fraction or look at the picture, please do that. But then please write it as a reduced fraction afterwards. How about drawing a 2 of diamonds? Well, there's only 1 of them. So I know it's a 1 out of 52 chance. So these are the theoretical numbers you're going to be experimenting with now. You're going to see, is this close to reality? But what you're going to be doing today is just grabbing the simulator that I'm going to put on Edsby that is drawing cards, and then you have to work with decks of cards. So first you're going to grab the card generator. First thing I want you to do is, instead of it drawing 2 cards, change it to 1 to enter. It'll reload that for you. Don't count this one as your first option. So the first thing that you're going to do, your lesson book asks you to think about the experimental probability of drawing a club. So club is the same as a clover. So I'm going to just keep track of how many times I draw on my finger. So I'm clicking draw for the first time. I got a club. So that happens 1 out of 1 time, 100% of the time. Record it. Experimental can be anything. So I'm going to write 1 out of 1. Now you're going to use the online simulator and you're going to see how long it takes you to draw a 7. So count how many times you draw until you hit a 7. And that'll be 1 out of however many times it took you to draw. Then you're going to use the online simulator until you can get that 2 of diamonds. Did it only take you 52 times? Did it take you more? Did it take you less? Did it take you the rest of the period? Go ahead and try to get the 2 of diamonds and record your experimental probability. When you're done with that, there will be some questions from your textbook to go ahead and practice this and to complete to wrap up today's lesson.